Look around. Our world runs on energy, and our global demands are astronomical.
Traditional sources like fossil fuels are finite and problematic.
Current renewables, while crucial, still face limitations of scale and storage. We need a radical, almost sci-fi solution that goes beyond batteries and solar panels.
What if the next great leap wasn't about size, but microscopic power?
We must ask the core question. What if the answer was incredibly small, yet infinitely powerful?
We introduce the theoretical concept of microcrystalline energy.
This is not just a tiny battery, but fundamental energy conversion. Imagine harnessing quantum fluctuations, the energy inherent in empty space, or utilizing vibrational resonance to generate clean power. Hypothetically, achieving cold fusion at the microscale within these crystals.
These visuals illustrate how these crystals might generate and store immense power.
A compact, high-density source that could reshape everything we know about power. This small core promises a world of limitless, clean energy.
A future unlocked by what looks like pixie dust.
Imagine a civilization powered entirely by microscopic crystals.
Clean air. Limitless resources for every inhabitant.
Even the ultimate dream, routine, cost-effective interstellar travel.
The transformative impact on manufacturing would be revolutionary. Transportation becomes energy independent and hyper-efficient.
Healthcare and personal devices gain limitless, portable power.
Socially, this promises an end to energy poverty.
The potential for a true post-scarcity society is real.
Liberating human potential from the daily struggle for basic power.
But the ultimate power carries the ultimate price.
We must address the critical ethical and security challenges.
The immediate risk of weaponization is terrifying. The temptation for centralized control and the misuse of this godlike power. The potential for societal collapse if this infinite resource is mismanaged.
We must consider the environmental risks of widespread, potentially uncontainable energy sources.
This technology prompts us to think about the responsibility that comes with godlike power.
Is humanity ready?
Are we morally and ethically prepared for this next step?
We ground this discussion in the current scientific frontiers.
The research draws heavily on advanced materials science.
Insights from quantum computing are crucial to understanding the mechanics.
And the immense precision required by nanotechnology research.
But we must highlight the current limitations and immense challenges to making this a reality. This breakthrough is not happening tomorrow. but requires years of rigorous work.
Yet, the human drive for advancement and innovation is our most powerful engine. We invite you to imagine and engage with these scientific possibilities, emphasizing the crucial role of responsible innovation as we move forward.
The future is not a destination. It's a possibility we engineer together. Thank you for watching. What breakthrough do you think will power tomorrow?
Leave your thoughts in the comments below.
Let's look closer at the underlying physics. Harnessing the residual energy in the vacuum of space.
The crystal's structure acts as a perfect resonator, stabilizing energy that would otherwise disperse instantly.
This touches on theoretical concepts like zero-point energy, once dismissed, now being re-examined. Compare this to modern batteries. Energy storage capacity that is virtually limitless in a negligible volume.
Imagine the infrastructure savings. No more power lines, pipelines, or massive oil tankers.
Transportation becomes truly decentralized, efficient, and environmentally friendly. Wearable technology could draw power directly from the environment around the user.
The crystalline core requires no input and produces zero waste or emissions.
This energy source revolutionizes food production and agriculture, eliminating reliance on energy-intensive systems. It democratizes power, making it instantly accessible to the most remote corners of the globe.
This is the realization of the post-scarcity society, driven by energy abundance. But the challenge is not scientific. It is fundamentally human. The crystal's portability makes it the ultimate, uncontainable weapon. Control over the power source equals control over the entire planet.
This presents immense ethical and security dilemmas for global governance.
The debate shifts from physics to philosophy. Should this power be centralized or distributed? Accidental misuse could have catastrophic, widespread environmental consequences. Will this be the great equalizer of humanity, or the great divider?
To ensure responsible use, global, transparent collaboration is non-negotiable.
We return to the lab. The breakthrough requires creating materials that do not yet exist.
Quantum computing is essential for modeling the specific molecular behavior required for the crystal core.
Nanotechnology must achieve unprecedented precision to construct this power source. The theoretical path is clear, but the practical engineering challenges are currently monumental. We face limitations in thermal management and stabilizing quantum effects.
This pursuit will require decades of patient research, failure, and reinvestment.
But history is clear. The biggest, most impossible challenges have always led to humanity's greatest leaps. The human capacity for innovation drives us to explore the seemingly impossible. The ultimate goal is not just power, but a sustainable future for all.
Your engagement in these discussions is vital for guiding responsible innovation.
The future is not pre-written. It is imagined and then engineered.
We have explored the crisis, the promise of the crystal core, and the immense shadow it casts.
The pathway is through materials science, quantum physics, and nanotechnology.
The answer remains a profound if, depending entirely on our dedication and wisdom.
Thank you for joining us on this deep dive into the future of energy.
If you enjoyed this journey, please subscribe for more explorations into radical science.
Like this video and share it with others who dare to imagine the future.
What fundamental law of physics do you think we will break next? Let us know below.
Check out our next video on the long-sought fusion challenge.
Connect with us on all our social channels.
Thanks for watching. We'll see you next time on Apex.